Thank you. Hello. Hello, check. Yep, awesome. All right. So let's get straight into this. A little bit about myself. I'm Peter. I'm based out of Bangalore, India. And I work at a company called Intuit. And I've been active in open source since 2004. So that's a long time, and hopefully I'll be able to share some of my experience and hopefully some insights in this session. I also happen to be the creator of an open source API testing framework called Karate. So I'll speak a little more about it. You'll hear something about Karate. And today's agenda is quite simple. I'll just break it down into three. I'll talk about what is WebDriver, a little bit about the architecture, and I do hope to do some demos, so wish me luck with live demos. There's a couple of things I want to be clear about, because WebDriver is actually a slightly overloaded term, and you heard Simon yesterday speak about, Selenium is a brand, and it basically encompasses three things: the language bindings, the IDE, and Selenium grid. And what could be confusing, and this is what I want to make sure is clear in this talk, what could be confusing is that the Selenium language bindings are also commonly known as WebDriver, right? So that said, what we're going to focus on is the W3C specification, which happens to be used by all these three pieces. And again, just to reinforce my point, today's focus, this talk, is going to be on the specification. Okay? And what is WebDriver? So now, whenever I refer to WebDriver, again, I'm referring to the W3C specifications. I'll go deep into that. The official specification is at this URL. As you all know, it's a W3C standard. It was made official recommended status in June 2018. That was last year. As you can imagine, and as Simon said yesterday, this is a big deal. I'll talk more about the amount of work it takes to actually get something like this as a standard and approved and all that. And a lot of people who work behind the scenes for this. This is the official definition of WebDriver as it appears on the specification page. So yeah, that's a lot of words, but let me try and break this down step by step and give you some additional detail that I hope is useful. WebDriver is a remote control interface, and it happens to be a REST API, and I'll talk more about that. It's quite simple, actually. WebDriver allows you to remote control web browsers. All of us know that. And it's a platform and language neutral via protocol. All of us know the beauty of REST and web services, so that completely applies to WebDriver. It's JSON over HTTP. Any language, any platform, it's easy to get up and running. WebDriver is a way for out-of-process programs such as Selenium to remote control not only browsers, but you could remote control mobile apps. You've heard of Appium, and even Windows applications, which I'll actually do a demo of. Yes, and these are the co-editors of the specification. All of you know the man on the left. David Burns, who works for Mozilla, is the co-editor. And there's a whole bunch of people working behind the scenes. If you need more details, you can visit the URL. You can see who is part of the working group. And by the way, this presentation contains a lot of links. I've tried to make it as useful as possible for those who download it. If you want to refer and look up more, feel free to download it once it's published. All right, so now we get into where does WebDriver fit in your work? All of us want to control browsers, right? And I'm going to introduce the term driver. Most of us know this already. It's a binary executable. That's whole purpose in life is to emulate a user, stand outside of a browser, but remote control it, and expose a REST API, which I talked about, which is the W3C WebDriver spec or the interface, in manager sessions, you need to be able to start a browser and manage multiple browser sessions. As I said, it exposes a REST API. And most of you are familiar with the bindings that you use directly. That's the language-specific SDK that you would use, which basically communicates with the driver over JSON and HTTP. And typically, you need a framework to do a little more higher-level stuff. I've given some examples there. You would want to do assertions if you're doing testing. Obviously, you want to run reports and things like environment switching, tags and groupings of tests and all that. So those concerns can be taken up by a framework. Now let us look at examples. Firefox means Gecko Driver, quite familiar. You can use Selenium Java. Again, these are examples. These are not exhaustive. I'm just going to show you some permutations which are representative. These are not exhaustive. So if you're a Java person, you'll be happy with this example. ChromeDriver. And here's the very interesting and important part about all this. The drivers are typically the responsible of the web browser vendors. It is the people who write the browser who are best capable of writing drivers, and that's what's happening. And that's actually one of the very important shifts that happened in the Selenium project, where earlier it was completely up to Selenium remote control. I'll talk a little bit about history. But this is a big deal, and as Simon said yesterday, it's incredible that everyone is coming together and doing this work. So it's a lot of a load taken out of Selenium project committers into the browser vendors. Ruby, Water, these are examples of where different pieces fit in the stack. If you like Python, you can use Selenium Base, just an example. This is interesting because there are frameworks like WebDriver and Nightwatch that directly implement the JSON/HTTP API. So that's also possible, and I'll talk more about that. And of course, Mocha is an example. Apologies to .NET and C# fans. I know there are some of you out there, but this is just an example, so it's not fully exhaustive. All right, so here's a little story about the Selenium project. Created in 2004, which is astounding, the number of years that this project has been around. I'm simplifying this slide a lot, and apologies if I've made mistakes. Please feel free to come and correct me later. But Jason Huggins created Selenium Core. Soon after that, Paul Hammond created the remote control that enabled us to remotely control Selenium Core with Selenium Server and all that. Mention about Selenium IDE. Interestingly, it's a Japanese developer who created it, the very original Selenium IDE, Shinya Kasatani. And then Simon Stewart, I think in 2006, he started thinking about this, and in 2007 made the first commit or push into the official repo of WebDriver. The big difference with WebDriver is that it's outside the browser. Selenium Core being JavaScript and being the fact that it is within the browser sandbox is severely limited in some ways. WebDriver avoids all that. Story is that Simon and Jason met at a conference and decided, hey, it is a good idea to merge the projects. I think Jason agreed that WebDriver is the right way to do it, is the right approach, the technically superior approach. This photograph is taken shortly after that decision. I think it's a Google Selenium meetup that happened in February 2008. Jason is on the extreme left. All of you know Simon. Shinya Kasatani is the glasses guy, fourth from the left. And that's Paul Hammond, fourth from the right. All right, the decision was made. Selenium and WebDriver projects began to merge with the release of Selenium 2. This happened. And it's at this point that work on the specification began in 2012. And again, you can see the amount of work that has gone into just drafting that spec, getting folks to agree and all that. Selenium 3 was released in 2016. Here, the big thing that has changed is it has deprecated Selenium RC and Selenium Core and all that. It's using the JSON wire protocol. Again, this diagram is an oversimplification maybe, but I've tried to capture the highlights. And what's happening today after the specification has been approved or it's become a standard is we're moving to everything being W3C only, as Simon talked about yesterday, right? And everything should happen through the protocol, the W3C protocol. Of course, Selenium ID has appeared. You've heard a lot about that yesterday. All right, so I said that WebDriver is actually nothing but a bunch of REST API endpoints. That's it. That's the whole list. I'm not going to go through all of them right now, but if I were to overlay the highlights, you need to be able to start a browser at the very top, session management, and you need to do interesting things like click on elements, and get information about the page and so on. All the things you would expect. And as Simon said, this is kind of he talked about Selenium bindings being the machine code of browser automation, and this is what makes it all work. So it's demo time, and what I'm going to attempt to do is prove to you that using very basic, simple, primitive HTTP commands, I'll be able to remote control Chrome. All right. So this is where I switch out into a terminal. Just trying to zoom in. I'm going to start, if I do ls, I have both ChromeDriver and Gecko Driver waiting to go. Started ChromeDriver, it's listening on port 9515, which is the default. Open a new browser window. And yeah, let me attempt to do something interesting. I'm going to cut and paste this bunch of text. All right, so the first one is going to actually start Chrome. Let's see if that works. Paste, enter, bam. So that's Chrome. And when this command executed, it actually gave you back a session ID, which I'm going to cut and paste. Let me just keep it here for ease of use. The second command is actually going to navigate to a URL. You can see the URL. I'm going to try and go to GitHub. And what I will do is try and show you the browser side by side. All right, here goes. All right, so remote control, it's going to GitHub. In order to do things, oops. Not what I wanted to paste. In order to do things with any element, you need to get an element reference back. That's what we're going to do. And we are looking up, this is the selector, which is hash login field, getting it by ID. Nothing's going to happen in the browser. And I got back an element ID, which I need for the next request. Over here, session, oops. And so if this works, we should see hello typed into that element. And there you are. So what I hope I have proved is it's very simple. You just need curl or postman or whatever HTTP tool you're comfortable with in order to do this magic of remote controlling a browser. So the next thing I'm now going to step this up a level. And I just wanted to talk about karate because I'm going to use karate as a guinea pig to do some of the demos. And some of the code that I've done is experimental. So, warning, this is not production ready yet. There is pretty much a lot of experiments happening in the GitHub of this project. For those of you who don't know karate, it's actually very useful for API testing. Yesterday, we heard a lot about the testing pyramid. So if you are running out of options in the top of the pyramid, karate is a great choice for you to actually focus your testing on the APIs. It's a layer that's easier to test and less flaky in many ways. And for those of you in Japan, I recommend that you check this link out. This is by Takanori Suzuki-san. Arigato Takanori-san. Because this is great. I think this really helped popularize karate a lot in Japan. All right. So as I said, this is all alpha. This is use at your own risk and all that. But I'm going to try and show you some demos of what we have achieved by trying to mix karate and WebDriver. And here's an interesting reason why I decided to try this out. Because I talked about karate. Karate is, in my mind, a very good HTTP client. It's very good at making REST requests. And guess what the W3C specification is? It's a bunch of REST endpoints. So I implemented the adapter, or the stuff that's able to now talk and understand the protocol. And karate has a lot of frameworky stuff that you expect from any testing framework. You can do assertions, express tests, tags, and so on. So I'm going to show you a demo of Chrome and ChromeDriver in a bit. And before that, I'll actually do this demo, which is very interesting because it's going to hopefully give you a sense of the power of the WebDriver specification, because we're not going to control a browser. We're actually going to control a Windows application, right? So I'm going to try that. And for that, I need to switch to my Windows VM, which hopefully hasn't slept in the meantime. Oh, great. Okay, that's a relief. This happens to be a karate script. Don't worry about the details, but I think you can get a sense of what this is going to do. This is going to bring up, I know this is a very simple demo. It's the Microsoft built-in calculator on Windows. And we're going to click 1 plus 7 equals, and we're actually going to assert for something to appear in a particular field. And you can run karate tests on the command line. So that is the feature file that I just showed you. And of course, it's Visual Studio Code. If some of you, I'm sure a lot of you have heard of Cucumber. So this is based on Cucumber. You see given, when, then, and all that, which is great because this is supported by most IDEs. You get syntax coloring. And so when I run this, it's going to happen very fast. So I'm telling you what to expect. You should see, if all goes well, the calculator come up and those buttons being clicked and so on. So that worked. And I'm also going to navigate to the report so that you can actually see what happened. And I think yesterday Simon talked a lot about traceability being one of the focus areas for the future. One of the things that karate does rather well is it actually allows you to see, and what I have done is actually switched on extended debugging. What is happening here is that you are seeing every single WebDriver request being made, each protocol message back and forth. And you can see we created a session here, and yeah, we got a session ID back, and yeah, we got a reference to the window. Let's see, how does a click look like? Get an element first. we got an element ID back, and fire a click. Okay, so again, here's the point. It's all very simple. It's HTTP. It's a bunch of post requests and get and delete requests. But that's all you need to be able to control, in this case, a Windows application, not a browser. I'm going to switch back to my Mac. And this happens to be another demo where I'm going to use Gecko Driver because I want to mix it up a little bit. This is a very simple script. You can probably read it and understand what's going on. We're first going to go to GitHub, attempt to log in with a login that does not exist. We're actually going to assert that the error message appeared. The next thing we're going to do is go to Google and fire a search for Karate DSL. And hopefully that works. All right. So this test actually would fail, and there's a very interesting reason. You saw it was a blog post by Shima Shima. I think he's here in the audience. And he's one of the first blog posts in Japanese on karate, so thank you, Shima Shima. And karate happens to have an HTML report, and I figured this out. It started failing when I came to Japan, and the reason is, apparently when you do a Google search over here, it brings up Shima Shima-san's blog post and not the karate homepage that works fine in the US and in India. So you can see that here it expected GitHub karate, but it turned up something different here. So that's an example of an assertion failure in karate and an example of an experimental WebDriver-based test. One more demo that I think I really wanted to show you is, I talked a lot about you need a framework. In this case, karate is taking the role of a framework over bindings. And one of the things that we've tried to do well in karate for API testing is parallel testing. And I just want to bring up this feature file. This is a pretty long test. This is kind of an attempt to create a kitchen sink kind of a test where you test all kinds of horrible HTML and JavaScript cases. But I wanted to show you this part. This is an example of data-driven testing using Cucumber. Most of you probably have seen this form of expressing tests. You can immediately see what we are going to do. We are going to try and bring up 3 different browsers at the same time. And just for dramatic effect, I'm going to position them layered or tiled across the screen. So let's hope this works. All right, so you see the tray icon. Yeah. So this is actually working, but Chrome, Firefox, and Safari. Yeah, there's a lot of trouble with weights and all that, so I'm actually doing some kind of polling magic. And the test passed. So I guess the point here is that if you do it right, you can achieve parallel testing even on one node. Again, by the way, this presentation doesn't contain any references to grid. I'm not covering that subject at all. I'm just focusing on how you control a browser. This is the Cucumber report for what we just witnessed as a test. 3 different browsers, and if you explode one of them, you will again see what I talked about. You can actually see WebDriver messages go up and down the wire. That's what a click should look like. You get an element reference, and yeah. Okay. So yeah, that was a lot. There's one more demo since I think I have time, which is, and what I'm going to attempt to show you is, some of the interesting things you can achieve once you are able to master the machine code of remote controlling a browser. And I'm just going to bring up this UI. So this capability is that this is very raw. Again, this is one of those beta things in karate that's been there for a while. But it's a demo of how you can actually step through a test script. So if I click this button, it should bring up Chrome. Okay, it's Firefox, I'm sorry. Yeah, Gecko Driver. And what's pretty cool about this, and one of the points I'm trying to make here is that because this is a very simple, straightforward way of talking to a browser, it's just making an HTTP request, and then you stop and you can wait. It's stateless. There's no tight, chatty connection like Simon talked about yesterday, which is what CDP or the Chrome developer protocol would be like. And because of this very neat way of fire a message, wait for the browser driver to do its thing and wait, we can do things like this, which is step through a script. Right? And you can even cause failures while you rerun a step. So this is pretty cool. Actually, this kind of debugging is something you may not be able to achieve with a standard IDE, because with IDE-based language debugging, you cannot go back in time and replay a step. So you can kind of do this here and so on. So to recap, I just showed you a demo of a framework using the WebDriver protocol to actually do a lot of amazing things. We talked to Chrome, which was the last demo I showed you. We actually were able to run multiple browsers in parallel, and we were able to even talk to a Windows application and do testing on it, right? And the same concept should apply to Appium or mobile-based testing. We haven't done those experiments yet, but it's potentially something we could look at. I'm done with the demo. So those are all the demos, and I just want to make a few more points before concluding. This is a recap of all the drivers that exist. And again, this presentation has a lot of links. In fact, watch out for the last 2 pages. The appendix section of this presentation has a whole exhaustive list of references. For example, if you're interested in the details of the history of Selenium, when it was released, who were the people involved, I've tried to do my best to go and do a historical, factual check and analysis and all that. So hopefully that's going to help you folks. Interestingly, the Internet Explorer driver, and yes, I know yesterday there were a lot of questions on Internet Explorer and people worried about legacy support and so on. But it's worth calling out, Jim Evans, who's been working hard on it. And it's worth reminding that, hey, end of support July 19, so I think after that point, only Edge and IE 12 and above is going to be supported, if I remember right. Jim is also responsible for the WebDriver compliance tests. And the reason I'm showing you this is there is a lot of work that goes on behind the scenes by the Selenium committers, right? And Jim talked, and yesterday Simon talked about how difficult it is and how incredible it is that so many people have come together. I talked about all the browser vendors in their own corners of the world, hard at work implementing the drivers as per the specification, and all this needs to come together for our world of web automation to work. And do check out that link, because that's the set of nightly, the periodic builds, checking that the Selenium drivers and the W3C implementations of each of the browser drivers are consistent or compliant with the spec. More about Jim, and this slide is to talk about or to reinforce the point I was making about how difficult it is to get all the browser vendors to conform, in a sense. And there's a lot of nudging and maneuvering that needs to happen behind the scenes. This is an example of subtly hinting to the browser teams that, hey, you're not so compliant, you need to hurry up, and so on. And as a result, this happened 2 weeks back, and you heard it from Simon yesterday that, hey, ChromeDriver, I think, is the last of the drivers to actually be fully compliant with the W3C spec. This has just been checked in. I'm not sure exactly the release number, where it will be available or whether it is already available, but there you are. In terms of general knowledge, I think most of you know this, but it's worth calling out. Most of you know that Microsoft decided to stop building their own browser and reuse Chromium. This is a little worrying and a little controversial, because it means that the world of browsers has kind of shrunk down to two major, it's like Firefox and Chrome, right, Chromium. But so the question is, hey, will this new avatar of Microsoft Edge continue to be supported for Selenium and WebDriver? And the answer is yes. In fact, John Jansen is an example of someone who works, he works in the Microsoft team for Internet Explorer, and he is pretty much committed on Twitter. When was this? This was again 2 weeks back, that, hey, things are okay, you can use the ChromeDriver in the time being, and we are busy writing our own specific driver for the new version of Microsoft Edge that would be based on Chromium. So we're nearly at the end, and this is a recap. I talked about bindings and I talked about frameworks. So just to be clear and to give you examples, if you want to go and refer to specific implementations, depending on the language of your choice, you can go and look these up. And of course, the bulk of the work by the Selenium committers themselves. So with that, this is pretty much a rehash of Simon's slides from yesterday, or Simon's keynote. I'm not going to attempt to get into deep, but this is just a call out that if you missed it, do go and check out the recordings of Simon's talk to get more details on the announcements of what you can expect in Selenium 4. It's going to be W3C only. There's a lot of work on scaling, cloud, tracing, the site and documentation which Manoj talked about yesterday. Friendly locators is being thought about and worked on. And you heard from Dave yesterday on the Selenium IDE, which is going to be a native app and support exporting into languages like Java and all that. So with that, I'm at the end of my presentation. So I can take questions. Thank you.
Thank you for amazing talk, Peter.
Thank you.
If anyone have a question, please raise your hand. Okay. Sorry, no stuff here.
Thank you very much for great presentations. And I was.
Sorry, Reggie. No problem.
Okay. Thank you. And you showed me a demo of Windows calculator, right? And I'm wondering if it works on other Windows desktop app, such as a sub-client, because my understanding is whether it works or not is depending on like how it is implemented, like what languages or what technologies it is built in. So can you elaborate on that?
Sure. I was just trying to look up a particular link as to where the web. The answer is WinApp Hang on. Let's see if I can bring that up. Yeah. This is very new. Microsoft released this thing called the WinApp Driver, right? The short answer to the question, I have not tried, right? But since I believe this is open source, I see a lot of potential in being able to customize this to able to do what you want. So if you have some legacy Delphi components or some weird controls written in C# of an old era and all that, I think there are some good chances that you can get it to work. So that's my answer.
Thank you.
Okay.
Yeah, in case Japanese question. Any other question? こちらの方。います。Wait, please. Now we are preparing.
Can I ask you some question about Karate API?
Sure.
Yes, I think the Karate API is a very helpful tool to our backend teams and backend engineers. They always require the API testing when they're working on. So I really want to know what is when is the beta release, the Karate API? Because the beta release is kind of reliable version, and I can recommend to use and try in our backend team to working on. So.
Okay, if I understood your question, are you asking whether Karate for API is stable and you can use it for production? Yes. Okay. Right. In fact, I'm sorry if I confused you. I'm saying the beta stuff or the alpha stuff and the experimental stuff is for Karate UI testing. All the WebDriver stuff is new. Karate API 2 years stable.
Got it. So I confused that there's only alpha version there, but already in the beta version, right?
Yes. So Karate is in version 0.9, right? For API testing, it is very stable.
Thank you.
Yeah. And as I said, there is a link to someone who has blogged about it in Japanese, but you can find many other references on Karate if you do a Google search. But yeah, it's pretty much stable, and if you have questions, feel free to come and talk to me about it. Thank you.
Thank you. Any other question? We have a little more time.
Hey again. Lovely talk. I kind of want to understand, might be a Google question, but easier here. How do you get the selectors, for example, for Windows apps? Because for like something in Chrome is super easy, right? You just inspect elements.
Yes, and I'm new at this. I'm going to admit I'm very much a newbie in how do you get hold of selectors for Windows apps. Part of the answer is in for example, again, I'm not going to attempt to dig and Google it here, but you get some sense of things you do in the Microsoft flavored version of WebDriver. But if I go to the test, and again, I'll have to log in. If you see, there are some changes, where you expect hash to represent an ID-based selector. It's this @ symbol, which means an accessibility ID in the Windows desktop application world. So there's some small changes like that, but basically, surprisingly, most of the rest is exactly as you would expect in terms of the spec. So hopefully that answers your question.
Yeah, definitely. Thank you.
Okay, last one question we have. Okay, yeah.
Thank you for the great presentation. So my question is since we already have the WebDriver working group, how does it work with the vendor itself? Sometimes they add new feature. Do we also have a kind of a collaboration on that, to make sure that new feature actually testable for us? Thank you.
Yeah, I probably defer to some of the committers, but my understanding is that the spec was kind of frozen in a particular version as a standard in June, like last year. But after that, if you go to the GitHub for the specification, right, you will see updates and check-in requests. In fact, it's open to all. That's one of the great things about the W3C specification. For example, it's very easy for you to sign up to be part of the working group, I think. Again, I'm not completely sure. But as like anything in open source, you can submit a pull request to the specification itself. And of course, provided Simon and Dave approve it, you can pretty much contribute to the spec. So that is continuing. I mean, I keep watching it actually, and there's been a whole lot of changes that happens, issues raised and so on. It's happening. Yeah.
Okay, now that's it, time to finish. Yeah, thank you so much, Peter. Please
Okay.
give big hands again.